Okay, so we're in section 4.5, rules of exponents. And the first thing we need to know is all of these properties. Okay, so we have product of powers, and that means in order to multiply powers with the same base, you are going to add their exponents. You'll see more of that in just a second. Quotient of powers says to divide powers with the same base, subtract their exponents. So the key here is they have to have the same base number in order for these properties to apply. All right. The third point is that a number or a variable that has no exponent, and you see up here on the board, I wrote it too, like the number 6, okay? That's the same thing as 6 to the power of 1. So if you see nothing there, that still means that there's an understood 1 there. That's really important. All right, so in example 1, we're finding the product of powers. Notice that in the first example, we have the same base of 2. When you have the same base, you can combine or add together your exponents. So we have 2 to the third times 2 squared. And that would be the same thing as adding my exponents, 2 to the third plus 2, to make 2 to the 5th. All right, and this middle step in between is very important for you to write on your homework tonight. All right, so when I'm multiplying numbers with the same base, I can add their exponents. So on the second one, I have 5 times 5 squared. But remember, we just talked about if there's nothing there, like on the first 5, we know that it's an understood what? 1 as an exponent. So that's 5 to the first plus 2, so that would make 5 to the third power. Go ahead and do the number 3, but make sure you include that middle step and you show what exponents you're adding together, but you only have to write the base once. All right, so I keep my common base, 4, and I add all my exponents together. 6 plus 4 plus 3 to get 4 to the 13th power. All right, so when I'm multiplying same base, I can add my exponents. Now the same thing applies with variables, okay? So if I have x to the 8th power times x to the 6th power, it's still the same base, it's the same variable. It's not x and y, they're both x, so I can write my common base and add my exponents, x to the 14th power. All right, go ahead and do numbers 2 and 3. Yeah, it's going to be y to the 5th power, and the third one? R to the 22nd power. Who got both? Who got both? Okay, so now we're going to switch gears over to quotient of powers. With quotient of powers, I'm subtracting my exponents. So multiplication, I add. Quotient or dividing, I subtract my exponents. And here's the rule that you need to remember. You subtract the numbers, and your leftovers go where the larger exponent is in the fraction. So on the first one, 8 to the 12th divided by 8 to the 6th, well, 12 minus 6 is what? 6. And since 12 is larger and it's on top, that's where your leftover 6 goes. Okay? So here's how you're going to write it. 8 to the 12 minus 6, and it's no longer a fraction because 8 to the 6th over 1 is the same thing as just 8 to the 6th. Your leftover exponents go where the larger exponent was in the original. All right, that's very important for you to remember for 4.6, because in 4.6, your leftovers might go in the bottom or they might go in the top. We don't know, okay? So it's just really important that you think of it that way. All right, for this section, your leftovers are always going to be in the numerator. All right, so go ahead and divide the other two, okay? So 9 to the 11th power minus what?
1.
Minus 1, because there's nothing there. 9 to the 10th power. On number 3. 5 to the 8th power minus 5 is 5 to the 3rd power. Quotient of powers. All right, now if I'm doing quotient of powers with variables, I still treat it the same way. Okay, go ahead and do your subtraction. Okay, and simplify these fractions using quotient of powers. Again, they all have the same base, so I can subtract my exponents. Okay, number 1, d to the 8 minus 3 is d to the 5th. Who got that right?
Me.
Okay. Number 2, x to the what? 15 minus 1, x to the 14th. Finish the third one. Everybody's going to get the third one right. Every single person in this class. You didn't raise your hand. All right. B to the what? 10 minus 7 is B to the third. Who got it right? Good. Okay. I think everybody got it right. All right, so we've actually already had this question. All right, well, can I use, this property when I have different variables as my base or different numbers as my base? So this slide is actually, helping us figure out, because let's be honest, on your, SAT test and your ACT test, it's not going to say in clear, bold letters, use the product of powers property. You have to be able to recognize when you can use it and when you cannot use it. Okay? Well, let's look at number 1. X to the 5th times x to the 7th. Yes or no, can we use product of powers?
No, yes.
Yes, we can, because they have the same base. What about number 2? No, we cannot use product of powers because they do not have the same base. One is 5, one is 4. Huh? Yeah, well, it's essentially in between examples. Okay? No, this is not going to be on the homework. Okay? So this is no. What about number 3? Yes or no? No, because they're different bases. Guys, it's as simple as, does it have the same base? If it does and you're multiplying, then yes, you can use it, or dividing. All right, so number 4, yes or no? No. Number 5, yes or no? Yes. Number 6, yes or no? It is yes. Again, so we can apply these properties only when we are multiplying or dividing by the same base. Have I said anything at all about addition and subtraction? No. So when I'm adding and subtracting, I have to use different rules. I have to use common terms rules, okay? So they have to be common terms in order to be able to add and subtract. All right, so now let's get over to example 2. Okay, product of powers with variables. Okay, numbers and variables. So if I had 2x to the 6th times 3x to the 9th. All right, so here's what I have. Now, instead of having a single term, I have 2 terms here, 2x. But notice that only one of them is raised to a power, which is the x. So here's what I can do. I can multiply the numbers together. 2 times 3. What's 2 times 3? 6. And now I take my common variable and I can add my exponent values. So I multiply the numbers, I take my common variable, and I can now add my exponents together to make 6x to the 15th power. All right? Okay, go ahead and try number 2. All right, so on number 2, what's 3 times 5? 15. X to the 1 plus 5. So 15x to the 6th. Who got 15x to the 6th?
I didn't even finish it.
Okay. All right, go ahead and do number 3. When you have the answer, raise your hand. Okay, so we have 14y to the 2 plus 3. Who got 14y to the 5th? All right, very good. All right, so now let's do some more of these. Okay, so now we've got these 2 problems. Okay, go ahead and solve numbers 4 and 5. Raise your hand when you're done. All right, so 2 times 3 times 2 is 12. A to the 1 plus 5 plus 2, 12a to the 8th. Now, I'm walking around. I saw some people did not write their step of adding, okay? Don't roll your eyes at me. I need it, okay? So, at least for this lesson, I need you to show me that you're adding. All right, now on number 5, 2 times 6 is 12. n to the 11 plus 8, 12n to the 19th power. All right, so that's product. Now we're going to switch over to quotient. Quotient of powers with variables. This is example 3. So notice now this is dividing with numbers and variables. Okay, so we need to reduce the fraction, and then we subtract our exponents from our common variables. 4x to the 8th over 10x squared. So how could I reduce 4 over 10? Yeah, divide by 2, so it's 2/5. Okay, now I go x to the 8 minus 2. And guys, another way you can remember this, okay, you subtract 8 minus 2 to get 6, and your leftovers go where the larger exponent is. Because 8 minus 2 is 6 and 8 is larger, my leftovers stay in my numerator. And like I said earlier in the lesson, on section 4.5, all of my leftovers will be in the numerator. On 4.6, sometimes the larger exponent is in the denominator and I leave them in the denominator. All right, so the easiest way to remember this is when it's division of the same the same variable, I subtract my exponents and leave the leftovers where the larger exponent is. Okay, go ahead and do numbers 2 and 3. Okay, so reduce 10 over 5, that's 2 over 1. I technically don't even need the 1. And then z to the 8 minus 3, and I leave my leftovers on top, but again, it's over 1, so it's just done. 2z to the 5th. Who got 2z to the 5th?
Wait, so
okay, we're doing good. We're doing good. Please stop.
What if you do leave the 1 there?
If you leave the 1 there, that's fine. Okay, so 20b to the 4th over 30b squared. Now I reduce it to 2/3. b to the 4 minus 2, I subtract my exponents and my leftovers stay in the numerator. Okay, because that's where my larger exponent is. Okay, so that's it for example 3. Now we need to shift over to example 4. There's 5 examples. Prepare yourself. Okay, so in example 4, guys, in example 4, I'm now applying both properties. Here's where it kind of comes together, and it can get, you can start mixing up your rules on accident. You have 2 terms in your numerator that can be simplified or combined. That's what you have to do first. 3m to the 5th times m squared. Well, that you have 2 variables with the same base, so you need to, would you add their exponents or subtract them? You would add their exponents, keep your denominator the same. 3m to the 7th. Does everybody see how we got 3m to the 7th?
Yes.
M to the 5th times m squared gives me m to the 7th. So now I'm dividing, and I can reduce my fraction and subtract my common exponents. All right, so 3/6 can reduce to what?
1/2.
1/2. And 7 minus 3 is 4. Does my m to the 4th go on top or bottom?
Top.
It goes on top. M to the 7 minus 3, I'm sorry. And it's going to be 1m to the 4th over 2. Technically, I don't even need the 1. All right? So the first thing you do is simplify the numerator or denominator, whichever one, and then you can divide, subtract, and get to your answer. Go ahead and try numbers 2. Go ahead and just try number 2. When you have the answer, raise your hand. Okay, so we get 10a to the 7th when we add our exponents over a squared. Did everybody get to this step? Okay, so now I'm dividing, so what do I do with my exponents? Subtract them. So sometimes we forget to subtract when we're dividing. All right, 7 minus 2. Now, what you need to understand, guys, is when I subtract that completely eliminates the a in my denominator. All right, think of that in the expanded form when we reduced. If there's 7 a's on top and 2 a's on the bottom, when they cancel, there's nothing left. It's just 1. Okay? All right, go ahead and do number 3. All right, what'd you get for number 3?
13.
I didn't finish.
13b to the third. 13b to the third. Very good. All right, now the last example. On the last example, we just need to go over now just some other ways that we could see this. All right, in the first column, they're looking for a less than, greater than, or equal to sign. So I need to simplify the right side to see what it's going to be. So I have 5 to the 7th power. What's 5 to the 3rd times 5 to the 4th?
5 to the 7th.
5 to the 7th power. So what goes here?
Equal sign.
An equal sign, and you box it in. All right, go ahead and do the second two. Do the second and the third one. All right, so 4 to the 3rd and 4 to the 4th, less than. 7 to the 4th and 7 to the 3rd, greater than. All right, here's the last one. You might see one of these on your homework. What value in my numerator could be divided by x to the 4th and give me x to the 8th? Quotient of powers, do I add or subtract my exponents? I subtract. So what number minus 4 gives me 8?
12.
So it's 12. Sorry, I messed up. Hold on. Okay, so it's going to be 12. All right, what about the second one? What number? 7 minus what gives me 3?
4.
What about the third one? 6 times, or 6 plus what gives me 15? 9. All right, so you just fill in the missing blank. All right, if you understand that, that's everything you need to know for 4.5.